Hello students, welcome to my channel AQ Digital Space, and today I have come up with a new topic of control structures. Control structures are basically responsible to control the flow of execution in a program or function, and there are three different categories in which the flow of execution takes place. The first one being the sequential control structures, in which the series of steps are in a perfect sequence. The next one is the selection, in which there is an ambiguity whether to handle one situation or the other situation, and in which the decision has to be made, or in other words, the selection has to be made. And the third one is the iteration control structures, which goes about repeating itself until a certain condition is met or until it meets the prescribed number of times it has to be executed. Talking about sequential control structures, as you can view in this image, the cars are actually present in a row and they are moving within a row, showing thereby the sequence of the cars or the queue in which the cars are moving. Likewise, the sequential structures are those statements which are executed in the same order in which they appear within a program. Here we are going to execute a few examples showing the sequential control structures. The first one being getting to drive a car. So when we talk about an algorithm, step 1 is start. 2. Call the instructor. Then take the classes, appear for the driving test, get the driving license, and step 6 is end. And when we talk about the flow chart, let's draw the flow chart together, starting off with the oval in the start, followed by a rectangular structure with the calling the instructor. Then take the classes within a rectangle, appear for the test again in a rectangle because these are all actions that need to be taken. And once you appear for the test, then it's time for the output, that is driving license is issued. And once the output is given, you end up with the oval. Example in which we are going to generate the sum of the two numbers. Talking about the algorithm first, start, read the two numbers, adding the two numbers, write the sum, and end. That means you are taking the input, adding it, and then giving the output. Now talking about the flowchart, we start off with the oval, read A and B both because these are two separate numbers that need to be read. Then a rectangle in which the action is to be performed, that is sum is equals to A plus B. After the sum is calculated, obviously it needs to be output or written to. So it is written on the screen as write sum within a parallelogram because this is supposed to be the output, and then you end the program. Once we have sorted out the flowchart and the algorithm, it's now time to execute the program. So we write down the comment generating the sum of two numbers, and hence we started off with include main. We initialize the two variables a, b, and then sum. All of them are of integer data type. We take it as the input, enter the two numbers, scanf, %d, because the format specifier for integer is %d, and then again %d because we have to enter both a and b, ampersand a to take the value of a, ampersand b to take the value of b, semicolon, sum is equals to a plus b. Here we carry out the mathematical operation and then we need to print the value. Sum of the provided two numbers is person D, because sum is defined as an integer and we define it like this. So let's execute this program. It's asking for the two numbers 2, 3, and hence the sum of the provided two numbers is 5. Control structure is to generate the area of the circle. So for this, first we'll design the algorithm. Start. Step 2, read radius of the circle. Calculating area is equals to 3.142 into radius. Write area, and then step 5, end. Now moving on to the designing of the flowchart. Start within an oval. Read radius, since it's an input, so it's enclosed in a parallelogram. Then we calculate the area within a rectangle. Again, we need to write the area, that is output the area, so we used a parallelogram, and then end. Let's execute this program in C. So we write the topic, generating the area of the circle. Moving on to, we initialize the radius as an integer data type. Then pi would be, is in decimal places, so it would be used as a float. And since an integer value multiplied by a decimal point results in a decimal number, so the area would also be a floating data type. Okay, now we need to ask the user enter the radius of the circle. Scanf to take the input. Since the radius is of integer data type, so we are going to use person D here and R. We will use this radius to calculate the area, is equals to pi multiplied by R multiplied by R. And then we will next output the value on the screen. The area of the circle of given radius is %f, because it is a floating point, so the format specifier for floating point is %f, and here we write down the area. Let's execute it. So it's asking for the radius. We are going to enter. Area of the circle of the given radius is 12.568 triple 0. So this is it. Students, now that we have completed a few examples and I have shown you clearly how the sequential control structures work, let's move on to carrying out an activity of our own. So we will draw an algorithm and flowchart for a program that converts temperature in degrees Celsius to Fahrenheit. So there is a formula for that, which is F is equals to 9 upon 5 multiplied by C plus 32. Using this formula, you will be converting the temperature in degrees Celsius to Fahrenheit. Best of luck. I hope you clearly understood the concept of sequential control structures. Don't forget to like, subscribe this video. Hope to see you soon in our next video. Thank you.